Hello, guys. So I'm going to continue where we left off. I'm reading chapter 4 of The Big Question, called Inventing the Universe, Our Strange World. If you wish to make an apple pie from scratch, you must first invent the universe. Carl Sagan. I cannot remember those words, but they keep coming back to me. Sagan is right. Everything we do, whether making apple pie, writing a book, or walking by a river, depends on the existence of the universe. Not just any universe, but the specific universe in which we live, which has certain properties that led both apples and human beings to come into existence. That's what it means for some, such as Richard Dawkins, it means nothing. The universe we observe. Let's begin our reflections on our universe at the very beginning. Once upon a time, people thought that the universe had always been with any dominant philosophical or scientific meta-narrative. The doctrine of creation was a theological statement about a universe that came to God's creation, not a specific explanation of how or when that happened. Augustine argued that God brought everything into existence in a single moment of creation, yet this created order was not static. God endowed it with the capacity to develop. The creation is meant to change over time, becoming what God intended it to be, rather than having been created in its final definitive form. Now Augustine does not develop these interpretations of Genesis as scientific theories. He is simply unpacking what he saw as the essential theological principles of the biblical creation narrative. How ways of reading Genesis mapped onto contemporary scientific narratives was a matter for discussion and debate. When the great intellectual renaissance of the Middle Ages began, Augustine's approaches to the evolution of the created order and the nature of time did not fit the dominant philosophical narrative of the day, and so were marginalized. Augustine was seen as a major, indeed the major, theological authority of that age. Yet Aristotle was widely regarded as the supreme scientific authority, and his ideas came to dominate the scientific theories at the time. Medieval science was thus committed to the idea of the eternity of the world, because this was such a significant feature of Aristotle's thought. This put Christian theologians in a difficult position. They, like Aristotle, especially his ideas on intellectual method, but they could not go along with his core belief that the universe had always existed. It seemed like an irreconcilable difference between science and religion, between Aristotle and Augustine. Both sides remained committed to their positions, and no reconciliation was really achieved. By the end of the 19th century, the scientific consensus remained roughly the same on the issue of the eternity of the universe. The great Swedish physicist Svante August Arrhenius, who won the Nobel Prize for Chemistry in 1903, wrote a best-selling work entitled Worlds in the Making. In this he argued for an infinite, self-perpetuating universe without beginning or end, based partly on the recent discovered principle of the indestructibility of energy. Arrhenius made clear his fundamental conviction that the universe in its essence has always been what it is now. Matter, energy, and life have only varied as to shape and position in space. Matter and energy might move around the universe. There was, however, no overall change within the system as a whole. This static view of the universe, which allowed for internal movements of energy and matter, but not for either origination or decay, remained the scientific consensus until the end of the First World War. Religious ideas of creation were regarded as outdated mythological notions, completely incompatible with cutting edge scientific knowledge. Then, slowly but surely, evidence began to accumulate, suggesting that the universe, far from being eternal, had an origin. It is a fascinating story, and we shall tell some of it in what follows. During the period between 1900 and 1931, astronomers witnessed three dramatic alterations in their view of the universe. First, the accepted value of the size of the star system increased by a factor of 10. Second, the work of Edwin Hubble led to the realization that there are other star systems beyond our own galaxy. And third, the behavior of these external galaxies indicated that the universe was expanding. The expansion of the universe was a difficult idea to accept at the time, as it clearly implied that the universe had evolved from a very dense initial state. In other words, that the universe had a beginning. Some resisted any such suggestions, sometimes fearing the potential religious implications of the idea of the origins of the universe. In 1948, the British astronomer Fred Hoyle and others developed a steady-state theory of the universe, which held that the universe, although expanding, could not be said to have had a beginning. Matter was continuously created in order to fill in the voids arising from cosmic expansion. Opinion began to shift decisively in the 1960s, chiefly on account of the discovery of cosmic background radiation. In 1965, Arno Penzias and Robert Wilson were working on an experimental microwave antenna at Bell Laboratories in New Jersey. They were experiencing some difficulties. No matter which direction they pointed their radio antenna, they picked up an unwanted and obtrusive background hissing noise which they simply could not eliminate. Their initial expansion of this phenomenon was that the pigeons roosting on the antenna were interfering with it. Yet even after the enforced departure of the offending birds, the hiss remained. This was only a matter of time before the full significance of this irritating background hiss was grasped. It could be understood as the afterglow of a Big Bang, a primal cosmic explosion, the existence of which had been proposed in 1948 by Ralph Alpher and Robert Herman. When seen alongside other pieces of evidence, this background radiation proved significant support for the idea that the universe had a beginning and caused significant difficulties for the rival steady-state theory. Since then, the basic elements of the standard cosmological model have become clarified and have secured widespread support within the scientific community. Although there remain significant areas of debate, this model is widely agreed to offer the best renaissance with observational evidence. The universe is now believed to have originated some 14 billion years ago and to have been expanding and cooling ever since. The two most significant pieces of evidence in support of this theory are the cosmic microwave background radiation and the relative abundance of light nuclei, such as hydrogen, deuterium, and helium, synthesized in the immediate aftermath of the Big Bang. This model entails this recognition that the origins of the universe must be recognized to be a singularity, a unique event, something which can never be repeated and hence never subjected to the precise experimental analysis that some hold to be characteristic of the scientific method. The theory was a dramatic development which caused a sea change in thinking about religious language concerning creation. It is often said by atheist apologists that science has eroded the plausibility of faith over the last century. Perhaps that may be true in some respects, yet in others it is demonstrably false. The standard cosmological model resonates strongly with the Christian narrative of creation, much to the annoyance of atheists such as Stephen Weisberg. We need to be clear that the Christian narrative of creation and the scientific narrative about the origins of the universe are not identical. As we saw earlier, science is rightly and distinctively committed to methodological naturalism. Yet any suggestion that the natural world is limited to what can be disclosed by the use of this method is ridiculous. It is a specific lens and angle of approach which is characteristic of the natural sciences. Only a crude scientific imperialism claims, arrogantly and wrongly, to be able to know nature in its totality. Science takes one angle of approach, other disciplines diverge, ultimately offering enriched and deepened understandings of our universe. Although some Christians have read their Bibles as teaching that the world is a mere 6,000 years old, it is clear that this is a figure that has been read into the text on the basis of a series of questions. That God created the universe, that this was good, and that it possessed an ordering in which some way reflects the divine rationality. There is plenty of theology, but no chronology. The scientific narrative of the origins of the cosmos is not the same as the Christian narrative of creation. The two can, however, be intertwined like a dual helix to offer a deeply satisfying vision of our universe. The theological notion of creation and the scientific notion of origination are not the same, in that they are framed in terms of different informing conceptual frameworks, yet there was now a convergence of intellectual focus between these religious and scientific narratives, leading to a synergy of possibilities that had arguably not been possible for 1,000 years, Creation and origination are to be seen as two different maps of meaning, two different levels of explanation for the universe. They are not identical. They are, however, increasingly been seen as complementary, mutually enriching. As scientific reflection on this strange universe continued, attention came to focus on two of its most puzzling aspects. Why can we make so much sense of it? And why does it seem to be fine tuned for life? Let's look at both these questions. What exactly do we mean by the universe? It is a word we use all the time without often thinking about what it means. It comes from the Latin word universum, meaning totality. It is generally taken to mean something like everything that exists. Yet this has become problematic. Let me explain. There's a major debate within cosmology at the moment about whether there is a single universe or a multiplicity of universes. Some physicists argue for a multiverse, an aggregate of universes, including our own. We will look at this more in detail later in the chapter, but you can see the problem. If these physicists are right, what we call the universe does not include everything that exists. It's just one universe among many. So should we stop using the word universe? No, there are two reasons for continuing to use it. First, the multiverse is still only a hypothesis and remains controversial. We do not know if there really are other universes yet. Secondly, we can easily retain the word universe to mean our universe. It's like splitting the atom. The word atom comes from the Greek root meaning indivisible, reflecting the idea that the atom was the smallest possible unit of matter. Now we know that this is not right. Atoms are made up of more fundamental components such as protons, neutrons, and electrons, but we still happily use the word atom. There is another word that we sometimes use instead of universe, and that is cosmos, from the Greek cosmos. Traditionally, its origin are traced back to the philosopher Pythagoras, who is said to have been the first to call the containing of all things the cosmos, because of the order which governs it. The Greek term cosmos thus developed overtones of order and intelligibility. The universe is something that we can understand. That insight is fundamental to the natural sciences, yet in many ways it is a surprising result. Not only is the universe governed by laws, these laws are comprehensible to us. As the philosopher Roger Scruton remarks, the idea that a universe left to its own devices will produce conscious beings able to look for the reason and the meaning of things is quite remarkable and demands some kind of reasoned explanation. John Polkinghorne, a theoretical physicist, noted for his work on quantum theory, is one of many to stress both the curiosity of this observation and its potential implications. Scientists are so familiar with being able to understand the world that most of the time we take for granted. After all, it is what makes science possible. And Polkinghorne points out things could have been very different. The universe might have been a disorderly chaos rather than an orderly cosmos, or it might have had a rationality which was inaccessible to us. What is particularly puzzling is why the deep structures of the universe can be repeated mathematically. How could the great untamable ocean of the universe be represented in a calm, shallow pool of mathematics? This point was made in a classic essay by the theoretical physicist and Nobel laureate Eugene Wigner entitled The Unreasonable Effectiveness of Mathematics. One of its closing sentences stands out for me. The miracle of the appropriateness of the language of mathematics to the formulation of the laws of physics is a wonderful gift which we neither understand nor deserve. When scientists try to make sense of the complexities of our world, they use mathematics as their torch. Sometimes abstract mathematical theories that were originally developed without any practical application in mind later turn out to be powerfully predictive physical models. We have gotten so used to this that we easily forget that this is strange. For Wigner, it was a mystery that called out for an explanation. John Polkinghorne concurs. Why, he wondered, is there such a significant congruence between our minds and the universe? Why does mathematics, the rationality experienced within, correspond so closely to the deep structures of the universe, the rationality observed without? He is not alone in being puzzled. But what explanations might be offered for this strange phenomenon? Of course, there are many possible explanations. It might be an extraordinary piece of good luck, even a miracle. Why should mathematics, the outcome of a free exploration of the human mind, bear any relation to the structure of the physical world around us? Now, some might suggest that we could leave it there. We do not need to worry about this, or even think about it. It works, and that's all we need to know. Most, however, will feel that this mystery demands an explanation. As Albert Einstein once remarked, the most incomprehensible thing about the universe is that it is comprehensible. What Einstein was getting at here is that the question of the intelligibility of the world is raised by science but goes beyond science's unaided ability to answer. It is a good example of the difficulty noted by the philosopher Ludwig Wittgenstein, who correctly pointed out that the meaning of a system will not be found within the system itself. Science is very good at raising profound questions, the answers to which turn out to lay beyond the scope of the scientific method. So is there what Eugene Wigner himself called a picture, which is a consistent fusion into a single unit of the little pictures that can accommodate this observation? Some would dispute that there is anything to explain. They would argue that the role of mathematics in basic physical theory is simply organizational, and that we impose meaning and structure on the world. There is thus no particular mathematical order within the universe itself. The human mind likes to organize things, and we are imposing our own ordering on reality by casting a mathematical net over it. The net creates order, but the order is invented, not real. This seems possible, but it is not compelling. As Roger Penrose and others have noted, it fails to explain the extraordinary precision in the agreement between the best physical theories that we have come across and the behavior of our material universe at its most fundamental levels. Penrose points to Einstein's general theory of relativity, which improves even upon the already amazing accurate Newtonian theory of gravity. Newton's theory was precise to something like 1 part in 100 in describing the behavior of the solar system. Yet Einstein's theory is not merely much more accurate. It also predicts completely new effects such as black holes and gravitational waves. Our minds can develop theories which do not simply explain what is already known, but can predict things we have not yet discovered. This is a particularly important point when viewed in light of the kinds of metaphysical Darwinism which writers such as Daniel Dennett and Richard Dawkins find so pleasantly excuse me find so puzzling persuasive. Dennett, the more philosophically literate of these two atheist evangelists, argues that human thought, including our morality and religion, is shaped by our evolutionary past. Without realizing it, we are the prisoners of our genetic history, locked into ways of thinking that were molded by our need to survive. And that is bad news for lots of traditional ideas such as God. Dennett sees Darwinism as a universal acid, a naturalist philosophy which corrodes religion and ethics, exposing them as relics from a past with no ongoing place in the present. Dennett's critics, of course, have pointed out that it is bad news for philosophy as well. If human rationality is grounded in our evolutionary past, why rely on it philosophically? The problems with the kind of approach favored by Dennett have been understood since the late 19th century. In his book, The Foundations of Belief, Arthur Balfour, a Cambridge academic who went on to become British Prime Minister, identified a central difficulty with the reform's evolutionary thinking gaining ascendancy at the time. A purely naturalist philosophy cannot account for the reliably scientific knowledge that we believe we possess. If science turns out to be true, this can only be the result of some beneficent accident. We have not merely stumbled on truth in spite of error and illusion, which is odd, but because of error and illusion, which is even odder. Having shown that naturalism was ultimately self-defeating, Balfour proposed his own solution to the enigma of our rational grasp of the universe. Humans can gain access to the truth only because the human mind has been shaped by a divine mind. It is, of course, not necessary to share Balfour's theism to appreciate the point of his argument. As writers as diverse as C.S. Lewis and Alvin Plantinga have shown, a rigorously naturalistic account of the foundations of human knowledge ends up locked into a self-referential argumentative argumentative circularity. If Dennett's inflated Darwinian narrative is right, the human mind is to be seen as having evolved in response to the need for survival. So, what reason is there for thinking that it can acquire deep knowledge of reality, such as the fundamental structure of the universe, when all that is needed in order for humans to reproduce their genes is that they avoid making fatal errors too often? There is no convincing evolutionary reason for our ability to develop the rich and complex mathematical theories of the day, speculate about the origins of the universe, or to focus on our chosen example, be able to represent the deep structures of reality mathematically. The concerns that Balfour then raised have not gone away, nor has the continuing realization that the Christian vision of God makes sense of what was not known until the 1700s. The capacity of a theory, a way of seeing things, to fit things in, to show that they are an interconnected part of a greater whole, is widely agreed to be an indication of its truth. Science does not work with that form of reasoning, but one of the most fundamental themes of scientific explanation is whether an observation can be satisfactorily accommodated within a way of thinking. This does not prove that a theistic lens is right, of course. After all, various forms of Platonism, which hold that there is a mathematical world whose existence is independent of us, also offer a framework for explaining this remarkable, even magical capacity of mathematics to map the deepest structures of the human mind. Perhaps it is not surprising that Platonism is frequently considered the default metaphysical position for mathematicians. Yet every scientist knows that there are multiple theoretical interpretations of every observation. There are lots of possible explanations. The question is, which of these is to be seen at the best? And like it or not, the idea of God remains one of the simplest, most elegant, and most satisfying ways of seeing our world. Why is there life in the universe? In the last few decades, there has been a growing realization of how the existence of life is dependent on the initial conditions of the universe. Life as we know it depends very sensitively on the form of the laws of physics and on some seemingly fortuitous accidents in the actual values that nature has chosen for various particle masses, force strengths, and so on. If we could play at being God and select values for these natural quantities by twiddling a set of knobs, we would find that virtually all of their settings would make the universe uninhabitable. Some knobs would have to be tuned with enormous precision if life were to flourish in the universe. This had led many to speak of the universe being fine-tuned for life. Many recent scientific studies have emphasized the significance of certain fundamental cosmological constants, which, if varied slightly, would have significant implications for the emergence of human existence. For more technical readers, examples of the fine-tuning of fundamental cosmological constants include the following. If the strong coupling constant were slightly smaller, hydrogen would be the only element in the universe. Since the evolution of life as we know it is fundamentally dependent on the chemical properties of carbon, that life could not have come into being without some hydrogen being converted into carbon by fusion. On the other hand, if the strong coupling constant were slightly larger, even by as much as 2%, the hydrogen would have been converted to helium, with the result that no long-lived stars would have been formed, and that such stars are regarded as essential to the emergence of life, such as conversion would have led to life as we know it failing to emerge. If the weak, fine constant were slightly smaller, no hydrogen would have been formed during the early history of the universe. Consequently, no stars would have been formed, and the biologically significant chemical elements of carbon, nitrogen, and oxygen were formed in the cores of stars, not in the original Big Bang. On the other hand, if it was slightly larger, supernovae would have been unable to eject the heavier elements necessary for life. In either case, life as we know it could not have emerged. If the electromagnetic fine structure constant were slightly larger, the stars would not be hot enough to warm planets to a temperature sufficient to maintain life in the form in which we know it. If smaller, the stars would have burned out too quickly to allow life to evolve on these planets. If the gravitational fine structure constant were slightly smaller, stars and planets would not have been able to form on account of the gravitational constraints necessary for coalescence of their constituent material. If stronger, the stars thus formed would have burned out too quickly to allow the evolution of life. In short, if the values of certain fundamental constants of the universe had been slightly different, life would not have been possible. Without carbon, oxygen, and nitrogen, there would be no life in the universe, no apples, and no human beings. We live in a universe which has apples and which has human beings who can use them to make pies. Modern cosmology helps us to realize that the seemingly commonplace existence of apples and humans is actually nothing less than astonishing. The simple act of making an apple pie is far more wonderful than many have grasped. Now, fine-tuning has become an accepted notion in modern cosmology, but what does it mean? It might, after all, mean absolutely nothing. There might be zillions of universes, and all the rest are barren and sterile. We just happen to be in the one that supports life. Our number came up, and we are here as a result. That is just the way things are. Yet the odds against a life-friendly universe are massive, unimaginably massive. The extreme improbability of life makes us wonder if we can really be satisfied with this explanation. As theoretical physicist and mathematician Friedman Dyson once remarked, the more I examine the universe and study the details of its architecture, the more evidence I find that the universe in some sense must have known that we were coming. And Dyson is not on his own here. The astronomer Fred Hoyle was notoriously hostile toward the idea of the origins of the universe, fearing that it would sound religious. Yet he was clear that there was something strange about the way the universe was set up. The common sense interpretation of facts suggests that a super intellect had monkeyed with physics as well as with chemistry and biology, and that there are no blind forces worth speaking about in nature. The number one calculates from the facts seem to be so overwhelming as to put this conclusion almost beyond question. So how does a theist like myself respond to these observations and comments? First, let's be clear that these observations prove nothing. Yet as philosophers of science such as Charles Peirce have emphasized, one of the goals of scientific explanation is to set surprising observations in a context which makes them seem unsurprising, perhaps even predictable. As I have stressed throughout this book, Christianity gives us big picture, a lens which brings things into focus. And if Christianity is right in its understanding of God, isn't something like that just what we should expect? So what might critics of the idea of divine creation say in response? In this section, we are going to look at two recent high-profile works from leading scientists who have argued that modern scientific thinking allows us to dispense with God altogether. I have chosen these two books on account of their cultural impact as judged by sale figures and associated stories in print and other forms of media. Stephen Hawking is one of the world's greatest theoretical physicists with a rare gift for popular communication. His most famous book, A Brief History in Time, stayed on the British Sunday Times bestseller list for a breaking record of 237 weeks. In 2010, Hawking teamed up with the American physicist Leonard Malloty now to write The Grand Design, an interesting account of unified field theories and superstring theories, along with a highly speculative ramble through philosophical and theological byways. The work attracted media attention mainly because of its bold statements of the explanatory redundancy of God. It is not clear whether these are to be tracked back to Hawking himself or to Malloty now. We do not need, they declare, to invoke God to light the blue touch paper and set the universe going. It was a vivid turn of phrase and got people talking, but what did they mean? Is there a blue touch paper which needs to be lit to set the universe going? And if God did not light it, who or what did? The Grand Design turns out to be a rather self-congratulatory manifesto of what somewhat crude scientific imperialism, which brashly and prematurely, as it turns out, declares that philosophy is dead, leaving the field clear for scientists to become the bearers of the torch of discovery in our quest for knowledge. This is nonsense, and the remainder of the book at least serves as a powerful demonstration of the continuing need for serious philosophy, if only to challenge and counter the inflated and muddled claims of some scientists. What Hawking and Malloty now provide is not pure physics, but a poorly argued metaphysics whose failings are all too evident. The basic idea of the grand design is that the laws of physics are adequate in themselves to account for the origins of the universe. We therefore have to choose between God and the laws of physics, as if they both could not be true or were somehow in mutual conflict, since they were baffled by what they were seeing. Can you tell us what's going on here? They asked me. It was an unwise question I have had. I've never been a great fan of cricket. However, I told it soared into the air. That's 6 runs, right? My new friend asked me. And sure enough, the scoreboard changed a moment later. They had grasped something of the rules of cricket. That lunchtime experience came back to me when I read The Great Design. Its authors seem to think that laws amount to agency. Laws are a description of what happens in certain situations or an enumeration of a summary or account of what happens within the universe. The laws of cricket did not cause the batsman to hit a six. The batsman simply hit the ball in a certain way, and the laws of cricket decreed that this was worth 6 runs. The batsman did all the work. The laws simply provided an interpretive or evaluative framework. Hawking seems to think that having laws makes things happen. It does not. Agency is one thing, explanation is another. And where did these laws come from in the first place? What explains the explainers? Surely there is a regress here, in which explanation is merely deflected rather than affected. It is a fair point to make, given that Hawking and Walloudenow hold that such a deflection can be used as an argument against God. It is reasonable to ask who or what created the universe, but if the answer is God, then the question has merely been deflected to that of who created God. It is a rather obvious point, but consistency is important in a rational argument. If Hawking and Walloudenow believe that the answer to the question who or what created the universe is the laws of gravity, then the question has merely been deflected to that of who or what created the laws of gravity. Maybe we still need philosophy after all. A second recent critique of the idea of creation is found in Lawrence Krauss's Universe from Nothing. Krauss, a professor of physics at Arizona State University, describes himself as an anti-theist and sees his understanding of physics as demolishing theism. Interestingly, Krauss had hoped to have Christopher Hitchens, a leading representative of the new atheism, write the preface to his book. Hitchens seemed to know nothing about science to judge by his pontifications on the matter, but he certainly shares Krauss's hostility toward religion. Having read Krauss's book closely, I think it is best seen as another of the new atheist critiques of religion rather than a serious attempt to think through the implications of science. In this work, Krauss argues that science is well on its way to explaining how the universe emerges from nothing without any need to reference the Creator God. I first read this book with eager anticipation since Richard Dawkins had declared it to be the best thing on the question of creation since Darwin's On the Origin of Species. Although I disagree with Dawkins on many points, when someone I regard as a leading atheist says this is the best atheist critique of religion, I have to take it seriously. Let me just say that if this is the best atheist critique of religion since Darwin, atheism is in a very bad place. Darwin's book, which I have read many times, is a brilliant articulate work of science based on rigorous argument and cautious understatement. And Darwin, in contrast to Dawkins, did not see Origin of Species as anti-theistic, nor did his leading interpreter, Thomas H. Huxley. Krauss's work is a sloppy-written, poorly argued atheist tract trading on the cultural reputation of science, which left me intellectually dissatisfied. The uncritical, effusive praise meted out for this disappointing work by the leading new atheist commentators does nothing to conceal its obvious argumentative and evidential failings. The first major section of Universe from Nothing focuses mainly on such over-discussed and not particularly controversial ideas as dark matter. It is only in the last 40 pages or so that Krauss gets around to discussing the issue of how something emerges from nothing. So what does Krauss mean by nothing? Here's what he says. By nothing I do not mean nothing, but rather nothing, in this case, the nothingness we normally call empty space. Krauss seems to think that that italicizing nothing solves a metaphysical problem when all it does is indicate that Krauss's nothing is not nothing at all. Krauss surely knows perfectly well that empty space is not really empty. There is something there. In the form of electromagnetic fields and virtual particles in the direct sea of particle-antiparticle pairs, empty space is thus not void, but contains transient electromagnetic waves and particles that pop into and out of existence. Nothing, as I understand the word, would mean an absence of fields of virtual particles and anything else. Krauss is not as Krauss is not a clear writer, and there are points at which it is difficult to follow his argument, especially toward the end of the work. But it seems clear that all he has succeeded in doing here is showing how something can emerge from something else. But that is just how the universe works. Maybe that's why Krauss used that important qualification, the nothingness we normally call empty space, my emphasis. Is this meant to imply that there is a popular understanding of empty space, which is to be contrasted with a more rigorously scientific account of empty space, which would begin by emphasizing that it is not empty at all? The last century has seen huge advances in quantum theory and has forced us to rethink many common sense notions, such as the idea of the emptiness of space. While space may be physically nearly empty, but it's populated with fields and forces, all of which have the potential to cause things to happen. David Albert, a professor of philosophy at Columbia University with a PhD in physics, put his finger on the central flaw of Krauss's book. If what we formerly took for nothing turns out, on closer examination, to have the makings of protons and neutrons and tables and chairs and planets and solar systems and galaxies and universes in it, then it wasn't nothing, and it couldn't have been nothing in the first place. But there is another issue. The laws of quantum mechanics do not actually help us to answer what we might call ultimate questions. They do not tell us why the universe should be made up of a particular kind of fields, or why it should have any kinds of fields in the first place, or why there should be a universe at all. They do not tell us where those fields came from. They give us an important, revisable intellectual framework to make sense of the workings of the universe. We can track its history and infer the principles that seem to govern its development and its present state of functioning. But we cannot say why the universe is there, just that it is there. The scientific narrative does not process the methodology which allows it to answer that why question, which would require access to whatever existed before the Big Bang, and at the moment that is simply inconceivable. The fact that the relation of the scientific narrative of origination and the Christian narrative of creation is being discussed with such enthusiasm makes it clear that this is no dead question. And it is clear, even on the basis of this very brief consideration of these works, that they do not have anything like the significance or impact on theism that some, perhaps, including their authors, might think. It is more complicated than they seem to realize. Finally, let's consider a question that emerges from recent scientific theories about the origins of the universe and concerns the nature of time. We naturally think of the origins of the universe as happening in time. In other words, we imagine a graph of the timeline, and at a certain point along that line, the universe comes into existence. Except it is not like that. We have to speak of the birth of space-time. In other words, both space and time came to existence, not time or space, but as time and space. Most of us find it impossible to visualize this. We are so conditioned to by living in a world of time and space that we cannot escape thinking in terms of time and space. Where were time and space before they came to be? It seems a hopelessly counterintuitive question, just as ridiculous as what is the universe expanding into. But we have to learn to adapt our thinking to the deeper structures of rationality. That is one of the core themes of the scientific method, not to be trapped into common sense or rational ways of thinking, but to let the universe tell us what it is really like. So what is the relevance of this 4-hour thinking about eternity? Most of us work with a common sense notion of eternity as an infinitely extended period of time. That is not what the word means. It means timelessness. Now, there are two important points to make here. First, Christianity understands, and it has always understood, God to be outside time. God creates the universe with time, not in time. It is virtually impossible for us to visualize this, as we are locked into habits of thought and mental image making that are shaped by the world around us. Christianity thinks of God creating space and time, not standing in space time and rearranging things that were already there. God therefore is not an object in the world, but someone who stands beyond our world. While the idea of heaven is notoriously difficult to visualize, we could think of it as a realm beyond the world of space and time that we presently know and inhabit. This poses imaginative challenges for us. C.S. Lewis suggests that we experience problems visualizing complex realities because we are flatlanders, two-dimensional people trying to visualize three-dimensional objects. Lewis invites us to imagine what it would be like to live in a two-dimensional universe and trying to visualize or describe a three-dimensional reality. Flatliners attempting to imagine a cube would either imagine the six squares coinciding and thus destroy their distinctness, or else imagine them set out side by side and thus destroy the unity. Lewis suggests that our mental difficulties, whether scientific or religious, arise from seeing things from a limited and limiting perspective. We cannot break free from the world that we know, yet we are invited to imagine a strange world that seems to operate by different rules. We think of time, we are invited to think instead of timelessness. In this chapter, we have reflected on some themes relating to cosmology. Now we need to move on and reflect on what many see as a game changer in the relation of science and religion, the controversies about evolution associated with Charles Darwin. Okay. Yeah. What the hell? Let me see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Okay. So yeah, that's the end of the of that chapter. I probably read the next chapter until tomorrow. Because I just checked and it's a long chapter. But yeah. So the next chapter that I will be reading tomorrow is I wanted to quickly take this time to say that I believe that this is my I would say 3, but I'm really going to go 2.5 because I started about the halfway point. Myself reading, like I vlogged half of that, all of the Yoga of Jesus, and then I'm doing all this. I think when I'm done reading the book, I mean, I'm still going to read more books after that, but I think I'm going to take a break from the vlogging. I mean, I'm going to continue to vlog, but at least just take a break from the vlogging of reading books, because I don't know if it's, you know, what you guys want or whatever, but I'm just doing it just to, you know, kind of get out of my head and everything. But I do want to share with you, just temporarily, a book that I'm going to be reading after the big question, and this is one I'm going to be reading on my own. It's called God No, Signs You May Already Be an Atheist, and Other Magical Tales. Now, the thing about this book and other books like it is that I'm not gonna probably agree with everything in the book, but I do find it to be, I am gonna find this to be a very interesting read, and it's basically, I kind of skimmed through the book and everything, but basically what this book is it's basically he lists the Ten Commandments, and he gives his atheist take on it. But the part of this book that really makes it interesting for me, and I've seen this in interviews, and it just makes me kind of intrigued, is he starts off the book with a credo, and it says, "If God, however you perceive him or it, told you to kill your child, would you do it? If your answer is no, then in my booklet you're an atheist. There is doubt in your mind. Love and morality are more important to you than your faith. If your answer is yes, please reconsider." And basically, what he's getting here is he's kind of referring back to the Abraham Isaac story where God tells Abraham to sacrifice Isaac as a test of faith. And, you know, I know that for me, if I had kids and I, for some reason, heard God's voice that told me to kill one of my kids, I would probably be like, I can't do that, you know? But this is definitely going to be an interesting read again. I probably won't agree with everything in the book, but there will be some things that I probably will, and there'll probably be some things that I will be kind of unsure where I stand. But I definitely am looking forward to this book. So that's what I'm going to be reading after the big question, and then there'll be other books as well. And I'll probably mention them briefly in some other vlogs that I do, as far as, you know, videos where I do other stuff. As far as, like, you know, finishing a book and then starting one again. But as far as like actually reading chapter after chapter, like, I probably won't do that for a while after this book. So, but yeah, that's my video today. Thank you for watching. Feel free to like, subscribe, and comment, and share. And guys, have a great day. Mom.